Good day. Welcome to session 13, Introduction. This study session is a continuation of the previous study session. Here we will discuss traditional and alternative methods for modeling and designing systems. Learning outcomes. When you have studied this session, you should be able to list, analyze, and discuss the traditional and alternative methods for building information systems. Traditional and alternative methods for modeling and designing systems. Traditional systems life cycle. The systems life cycle methodology maintains a very formal division of labor between end users and information system specialists. Technical specialists, such as system analysts and programmers, are responsible for such of the system's analysis, design, and implementation work. End users are limited to providing information requirements and reviewing the technical staff's work. The life cycle also emphasizes formal specifications and paperwork. So many documents are generated during the course of a system project. The system's life cycle is still used for building large complex systems that require a rigorous and formal requirements analysis, predefined specifications, and tight controls over the system building process. However, the system's life cycle approach can be costly, time-consuming, and inflexible. Although systems builders can go back and forth among stages in the life cycle, the system's life cycle is predominantly a waterfall approach in which tasks in one stage are completed before work for the next stage begins. Activities can be repeated, but volumes of new documents must be generated and steps retraced if requirements and specifications need to be revised. This encourages freezing of specifications relatively early in the development process. The life cycle approach is also not suitable for many small desktop systems, which tend to be less structured and more individualized. Prototyping. Prototyping consists of building an experimental system rapidly and inexpensively for end users to evaluate. By interacting with the prototype, users can get a better idea of their information requirements. The prototype endorsed by the users can be used as a template to create the final system. The prototype is a working version of an information system or part of the system, but it is meant to be only a preliminary model. Once operational, the prototype will be further refined until it conforms precisely to users' requirements. Once the design has been finalized, the prototype can be converted to a polished production system. The process of building a preliminary design, trying it out, refining it, and trying again has been called an iterative process of systems development because the steps required to build a system can be repeated over and over again. Prototyping is more explicitly iterative than the conventional life cycle, and it actively promotes system design changes. It has been said that prototyping replaces unplanned rework with planned iteration, with each version more accurately reflecting users' requirements. Steps in prototyping. Step 1. Identify the user's basic requirements. The system designer, usually an information systems specialist, works with the user only long enough to capture the user's basic information needs. Step 2. Develop an initial prototype. The system designer creates a working prototype quickly using tools for rapidly generating software. Step 3. Use the prototype. The user is encouraged to work with the system to determine how well the prototype meets his or her needs and to make suggestions for improving the prototype. Step 4. Revise and enhance the prototype. The system builder notes all changes the user requests and refines the prototype accordingly. After the prototype has been revised, the cycle returns to step 3. Step 3 and 4 are repeated until the user is satisfied. When no more iterations are required, the approved prototype then becomes an operational prototype that furnishes the final specifications for the application. Sometimes the prototype is adopted as the production version of the system. Advantages and disadvantages of prototyping. Prototyping is most useful when there is some uncertainty about requirements or design solutions, and often used for designing an information system's end-user interface, the part of the system with which end users interact, such as online display and data entry screens, reports, or web pages. End-user development. Some types of information systems can be developed by end users with little or no formal assistance from technical specialists. This phenomenon is called end-user development. A series of software tools categorized as fourth-generation languages makes this possible. Fourth-generation languages are software tools that enable end users to create reports or develop software applications with minimal or no technical assistance. Some of these fourth-generation tools also enhance professional programmers' productivity. Fourth-generation languages tend to be non-procedural or less procedural than conventional programming languages. Procedural languages require specification of the sequence of steps or procedures that tell the computer what to do and how to do it. Application software packages and outsourcing. Firms can rent the software from a software service provider. They can purchase a software package from a commercial vendor, or they can have a custom application developed by an outside outsourcing firm. Application software packages. During the past several decades, many systems have been built on an application software package foundation. Many applications are common to all business organizations. For example, payroll, accounts receivable, general ledger, or inventory control. Outsourcing. If a firm does not want to use its internal resources to build or operate information systems, it can outsource the work to an external organization that specializes in providing these services. Cloud computing and SaaS providers are one form of outsourcing. Subscribing companies will use the software and computer hardware provided by the service as the technical platform for their systems. In another form of outsourcing, a company could hire an external vendor to design and create the software for its system, but that company would operate the system on its own computers. The outsourcing vendor might be domestic or in another country. Domestic outsourcing is driven primarily by the fact that outsourcing firms possess skills, resources, and assets that their clients do not have. Installing a new supply chain management system in a very large company might require hiring an additional 30 to 50 people with specific expertise in supply chain management software licensed from a vendor. rather than hire permanent new employees, most of whom would need extensive training in the software package and then release them after the new system is built. It makes more sense and is often less expensive to outsource this work for a 12-month period. Rapid Application Development, RAD. Object-oriented software tools, reusable software, prototyping, and fourth-generation language tools are helping systems builders create working systems much more rapidly than they could using traditional systems, building methods, and software tools. The term Rapid Application Development, RAD, is used to describe this process of creating workable systems in a very short period of time. RAD can include the use of visual programming and other tools for building graphical user interfaces, iterative prototyping of key system elements, the automation of program code generation, and close teamwork among end users and information system specialists. Simple systems often can be assembled from pre-built components. The process does not have to be sequential, and key parts of development can occur simultaneously. Sometimes a technique called Joint Application Design, JAD, is used to accelerate the generation of information requirements and to develop the initial systems design. JAD brings end users and information systems specialists together in an interactive session to discuss the system's design. Properly prepared and facilitated, JAD sessions can significantly speed up the design phase and involve users at an intense level. Agile development focuses on rapid delivery of working software by breaking a large project into a series of small sub-projects that are completed in short periods of time using iteration and continuous feedback. Component-based development and web services. We have already described some of the benefits of object-oriented development for building systems that can respond to rapidly changing business environments, including web applications. To further expedite software creation, groups of objects have been assembled to provide software components for common functions such as a graphical user interface or online ordering capability that can be combined to create large-scale business applications. This approach to software development is called component-based development, and it enables a system to be built by assembling and integrating existing software components. Increasingly, these software components are coming from cloud services. Businesses are using component-based development to create their e-commerce applications by combining commercially available components for shopping carts, user authentication, search engines, and catalogs with pieces of software for their own unique business requirements. Web services and service-oriented computing introduced web services as loosely coupled, reusable software components delivered using extensible markup language, XML, and other open protocols and standards that enable one application to communicate with another with no custom programming required to share data and services. In addition to supporting internal and external integration of systems, web services can be used as tools for building new information system applications or enhancing existing systems. Because these software services use a universal set of standards. They promise to be less expensive and less difficult to weave together than proprietary components. Web services can perform certain functions on their own, and they can also engage other web services to complete more complex transactions, such as checking credit, procurement, or ordering products. Study session summary. In this study session, we discussed how building new systems produce organizational change, the core activities in the systems development process, the principal methodologies for modeling and designing systems, the alternative methods for building information systems, and the new approaches for system building in the digital firm era. End of CIS 102, Study Session 13. Thank you for listening.